All right, these are the questions from 7.1 in your Math Links Grade 9 book on multiplying monomials by monomials. So the first question we have to do says, explain to a partner at least two ways you could find the product of 3x and 5x. Well, the first way that we learned was to model it. And if we think about 3x as being a length of a rectangle, now if I was to use just a basic old rectangle and put 3x here, that's the same thing, and do 5x for its length, positive x's, then if I was to fill in, well, this is really bad, fill in this rectangle, then we could see, I should have done these in solid lines. My brain's not working. It's Thursday, last period. If I fill it in, an x multiplied by an x would mean this tile is an x squared, which means I need to shade it in positive because they are all positive x by positive x. So each of these internal area is x squared, and if I look at it, I would have 15 x squared. If the length is 5x and the width is 3x, then I could see from algebra tiles that my area would be 5x. One way it's modeling. The other way you can do it is to think about 3x multiplied by 5x as the product of parts. So it's 3 multiplied by x, that's what 3x means, multiplied by 5 multiplied by x, or 3x times 5x. And we know, according to the associative property of mathematics, the order in which you multiply terms does not matter. So instead of doing it this way, I could rearrange my 3 and my 5, which are my coefficients, together, and my x together. And what I would end up with is, of course, 3 times 5 being 15. And x times x, you could leave it xx if you wanted to, but we learned in the chapter 3 for exponents that a number multiplied by itself or a variable multiplied by itself can be expressed in exponential form. So x times x would be x squared. So your solution would be 15x squared using redistribution of parts. In question 2, it says Lori used the following method to divide 16n squared by 2n. She wrote down first 16n squared divided by 2n, and then she said, well, 16 take away 2 is 14, and n squared take away n equals n, so therefore it must be 14n. Well, first of all, Lori has a lot of learning to do, because both of those things that she did, both this one here and this one here, are incorrect ways to tackle this question. So this is wrong for two different ways. The first thing is, what she should have done is she should have, instead of subtracting those, she should have done 16 divided by 2. 16 divided by 2 would have been 8, not 14. And the next thing she should have done, so she should have done 16 divided by 2, meaning divide the coefficients, and then take her n squared and divide it by n. And if we go back to your chapter on exponential form, when you have like bases and you're dividing them, the rule is, remember this is a 1, is keep the base and subtract your exponents to give you n to the exponent of 1, or simply n. N squared take away n cannot be done. It can't be done because you can't add or subtract powers that don't have the same exponents, right? You have to have the same base and the same exponents to add or subtract them, right? You can't actually subtract an n from an n squared. Question 3, what multiplication statement is represented in each set of algebra tiles? So it's looking for a multiplication statement. Now remember, just hypothetically, if this was a 4 and a 2, the area would be 8, because we would say the length times width is the area. So here, instead of having 4, 2, and 8, we're using 3x as its length and 2x as its width. And we can clearly see from algebra tiles that the area, or the inside of this particular rectangle, is 6x squared. So therefore, 3x multiplied by 2x is 6x squared. So what multiplication statement? It would be 3x multiplied by 2x equals 6x squared. Question B would be 3x, which is your length, multiplied by the width, which this time is a negative 2x. And since this length here is x and its width is negative x, x times negative x, or x times x is x squared, and a negative times a positive is a negative. So each of these white unshaded in tiles represent a negative x squared. So equals negative 6 x squared. And finally, question C. Our length is negative 3x. Our width is negative 2x. So when I multiply negative 3x by negative 2x, negative 3 times negative 2 is positive 6, and x times x is x squared. So the solution would be a positive 6x squared. Now you could have, if you did this on the test, it's still the same thing. You're not going to, the order in which you multiply length and width, there is no defined, this comes first, this comes second. So either one of those is the same. Again, because of the associative property of mathematics. Question 5 says model and complete each multiplication statement. So the first one, 2x times 4x. I'm going to draw my area model. I'm going to put 4x up here, 1, 2, 3, 4. Shade them in because they're positives. Times 2x, which is down here, positives. Complete this. And since it's a positive times a positive, all these will be positive, and therefore the answer is 8x squared for number A. Question B says negative 4x times 2x. So if I go back to what I drew in the last one, the only difference between these ones and the one I'm doing right here is, where's my eraser? Oh, it's right here. Is if I take my eraser, these 4x's up here, oh, that's not an eraser. These 4x's up here are going to be negative instead of positive. So it's a negative and a negative and a negative and a negative. And the answer, the ones inside here, because it's a positive times a negative, all of these are going to end up being negative. And my answer would be a negative 8x squared, because it's almost the exact same question as the one before it. In question C, the difference between A and B is that this time, these two things here are both going to be negative. So I'm just going to replace them with, now we have negative 4x times negative 2x, and a negative times a negative is a positive. So all of these are going to become positive, and the solution to this one will be a positive 8x squared. And finally, the last one, if I go back in time, I have negative 2x multiplied by a positive 4x, so I'm going to change these to positives. And a negative times a positive is a negative, so we're going to have negative 8x squared for my solution modeled for D. Question 7 says find the product of each pair of monomials. Now, obviously, it does not say model it, so you probably don't want to model it. But here what we're going to do is we're going to simply think about this as being, I'm going to write it once and then I won't write it again. If we rearrange the terms in the product of those things, instead of saying 2 times y times 5 times y, I said 2 times 5 times y, just to rearrange all four parts to the product. I would end up with 2 times 5 being 10, y times y being y squared, and the solution would be 10y squared. Here, if I think about it as being 3 multiplied by a multiplied by negative 6 multiplied by b, and if I rearrange them, I get 3 multiplied by negative 6 multiplied by a and multiplied by b. So the first part, negative 18, is easy, but when you have a times b, or a variable a multiplied by a different variable b, you can't combine them into an exponential form because they don't have the same base. So you must leave them as simply the product of a and b, which we will express as ab, which means ab means a times b. So the answer is negative 18 ab. Question C. Now, a negative q is the same thing as a negative 1q. The coefficient of negative 1, we never write coefficients of 1, and we never write coefficients of negative 1, but they're understood. So we know that that's a negative 1 coefficient. The reason why I say that is because in C, you need to combine your coefficients first. So a negative 1 multiplied by a negative 9 is a positive 9. So the negative 1 and the negative 9 are gone. And a q times q is q squared. So your answer is negative 9 q squared. positive 9. Did I say negative 9? Sorry, positive 9q squared. In the next one, it's 2/3 multiplied by x, multiplied by 3, multiplied by x. When I rearrange the coefficients, I have 2/3 multiplied by 3, multiplied by x, multiplied by x. And 2/3 times 3 is a grade 8 learning outcome when you multiply a fraction by a whole number. So 2/3 multiplied by 3. And I think back in grade 8, the way you learned it is because it's a whole number. Some people like to think of 3 as being 3 over 1. And the reason why we like to do that is when you multiply your numerators, you get 6. And when you multiply your denominators, you get 3. And 6 over 3 in lowest terms is simply 2. So 2/3 times 3 is 2. X times x is x squared. So your solution for D would be 2x squared. For E, negative 3 times negative 2 is... Question E, negative 3 times negative 2 is a positive 6. R times T cannot be simplified beyond R times T because they're not like terms and cannot be expressed as a simplified exponent. And finally, 1.5 times 3 is 4.5, which will be a negative 4.5 because 1.5 times negative 3 is negative 4.5. And P times P will be P squared. Question 9. A rectangle has a width of 3.9x and a length of 5x. So if I wanted to draw it, I'd have 3.9x and 5x. What is an expression for the area of the rectangle? Well, obviously, length times width equals area. The length could be 5x multiplied by the width of 3.9x, and therefore 15 at 4.5 is 19.5 x squared would be the area. So there's the expression that represents the area, and there's the area itself. Question 10 says a parallelogram has a base of 8.1z and a height of 4.2z. What is the expression for the area of the parallelogram? Again, parallelogram's area, you might have forgotten this because it's a grade 7 outcome, is base times height, or 8.1z multiplied by 4.2z, and that's the expression that represents the area, and the actual area would be 30, I can't do that in my head, 8.1, thank you, 34.02 is the combined of the coefficients. Z squared would be the algebraic part. And since we're dealing with area, I should probably say, since it's not units, square units, whatever these happen to be. So 34.02 z squared units squared is the area. Question 11, write a division statement represented by the area of algebra tiles. So remember, area equals length times width. And if I divide both sides by, let's say, length, that creates like a coefficient divided, like back in algebra, I'm left with width equals area divided by length. So if we think about our area as being 6x squared and our length being 3x, then 6x squared divided by 3x will be the missing width. And if I work that out, 3 divided by 2 is 2. X squared divided by x is x. So therefore, the missing width of this particular model would be 2x. Here, negative 6x squared divided by negative 2x. That means my length has to be positives, because a positive divided by negative is a negative, and therefore the answer is 3x. Question C, negative 6x squared is your area, divided by the one width we know, which is positive 2x. Negative 6 divided by 2 is negative 3, and x squared divided by x is x. So here we would have 3 negative x's as our length. Question 13 through A, B, C, D. We said we didn't have to do B because we're not going to model with y's. So we'll look at the rest of them. So for this one, if you're given 8x squared divided by 2x, so we're going to start with this one. What I would advise you to do is first draw the length that you know. So in this case, 2x. Draw that first. And the reason why is I have to fit 8x squareds into there. So if I draw it like this, there's my 8x squareds. Those are positives. It helps me fit it in because I know exactly how to do it and how to get it evenly. And then I know, based on the modeling, that each of these have to be a positive x. So therefore the solution would be 4x. Right here. 4x. B we're not doing. So C, I'm going to take my 4x and draw it first. 1x, 2x, 3x. Oopsie daisy. 4x. And into there, I have to have an area of 12x squared. There's my 12x squareds, but they're negative, which means these ones up top have to be negatives because a positive times a negative is a negative. So therefore, the solution is negative 3x. And your last one, I'm going to put my negative x here first, and then I'm going to put my positive 2x squareds in here. And say, what is the length? Well, here it has to be negative 2x because a negative times a negative is a positive. So your answer is negative 2x. Question 15 simply says to find the quotient. So 7 divided by 1 is 7. Remember, there's a 1 coefficient that we don't write there. X squared divided by x is simply x, so our solution for the first one is 7x. 25 divided by 5 is 5. S divided by s is 1. So multiplying by 1 does not affect it, so we won't bother writing it. In essence, an s divided by itself cancels each other out. And I'm left with a t by itself, so the answer is 5t. Here, 125 divided by 5 is 25. T stays by itself, so it's 25t. Negative 8 divided by negative 2 is 4. M divided by m makes 1, but 4 times 1 is still 4, so we're going to leave it as just a 4. 81 divided by 3 is 27. R divided by R and S divided by S cancel each other out, so we're left with 27. And 4.5 divided by 3 is 1.5, but it's going to be a negative 1.5. And a p squared divided by p is simply p, so we have negative 1.5 p. Now, you don't have to rearrange it if you don't want to, but for me, I'm kind of set in my ways. I like to see it like this myself. So if you want on a test, if you're given a question that looks like this, and you like to see a certain way because your brain works that way, like mine does, rewrite it like this, and you're going to see the answer of being 12.4x easier, I think, this way, but you might not. So for the second one, 0.6t squared divided by 0.2t squared. 0.6 divided by 0.2 is 3. And t squared divided by itself cancels each other out, leaving me simply with 3. Now the next one's interesting, and it's very important that you rewrite it as k over 4k. Now, I'm going to write the 1 coefficient that I said never to write. Well, I'm going to put, because it is 1k, but we never write the 1 coefficient, but it's important now. Because 1 divided by 4, when I do this, is either going to be 0.25 or just 1 over 4, right? It's not 4, right? And k divided by k cancels each other out. So your answer for this one is 0.25 or if you want, 1/4, okay? That's what's done. A lot of people probably had that one wrong. But the coefficient of 1 divided by the coefficient of 4, coefficient of 1 divided by the coefficient of 4 is 1/4. Okay, so your answer is 1/4 or 0.25. Because k divided by k cancel each other out. In B, negative 15r over negative 4r. 15 divided by 4, well, 15 divided by 2 is 7.5. Divided by 2 again is 3.75, but I better double check because my brain's not working so well. Good. So positive 3.75 is your answer because r divided by r cancels each other out. D I'll do down here. Negative 18pn divided by 3n. Negative 18 divided by 3 is negative 6. P stays by itself and n cancels the other end out. And finally f, 2/3 x squared over 2x. Let's start with our variables first. X squared over x is going to leave me with x. Now 2/3 divided by 2 is essentially what we're doing here, correct? 2/3 divided by 2. 2/3 divided by 2. So back in grade 8, when you learned how to divide fractions by whole numbers, you learned that the easiest way to divide them was change your division to multiplication and use the reciprocal of 2. And the reciprocal of 2 is 1/2, right? When you flip 2 upside down, it becomes a half. And then when you multiply that out, you will end up with 2/6, which in lowest terms is 1/3. So 2/3 divided by 2 is 1/3, which makes sense if you really think about it. If you have 2/3 of a chocolate bar divided between 2 people, each person gets 1/3 of a chocolate bar. But your solution for the last one is 1/3 x. Questions 17 and 18 and 19, 17, A, B, and C have to do with areas of different figures using formulas and algebraic terms. So the area of this is going to be length times width, or 11x multiplied by 3x, or 33x squared is the area. The area for B, a lot of people had it wrong, but pay attention. It's base times height divided by 2, or 10p multiplied by 4p divided by 2, or 40p squared divided by 2, which is 20p squared as an area. Right, half of 40p squared would be 20p squared. And the last one, your area is side squared. So it's 1/2 w squared. Now for me, I'm going to stop for a second and say half of w. We, to this point in our algebraic experiences, we have not used half of w squared. But if we think about it, I can apply the w since there's multiplication in the brackets to both parts. So 1/2 multiplied by 1/2, and w multiplied by w is how I'm going to solve that. 1/2 times 1/2 is 1/4. W times w is w squared. So my answer is going to be 1/4 w squared, or 1/4 of w squared. If you want to get really technical, you can write it that way. 1/4 of w squared is written this way, or 1/4 of w squared could also be written that way. Both are the same thing. Alternatively, 1/2 of w multiplied by 1/2 of w. 1/2 times 1/2 is 1/4. W times a w is w squared. If you want to think of it without exponents of 2, because it's a little confusing for some people, you can just think of it as the product of a side and a side, or a length and a width. And we'll still end up with 1/4 w squared. Question 18. What is the missing dimension of each figure? So here, just like the modeling, you're given the area. So area equals, I'll just review it one more time, length times width. If I divide both sides by length, the width will equal the area divided by the length. The area divided by the length will be the missing width. So 15 divided by 5 is 3. X squared divided by x is x. So therefore, the missing length or width is 3x. Now here, B is a tough one, because you have to use your formula. So base times height divided by 2 equals area. Okay, so if I multiply both sides by 2, then base times height equals 2 areas. Right? Remember back in grade 7 when you took a parallelogram and you put 2 parallelograms parallelograms together, you made a, or two triangles together, you made a parallelogram. And they said, well, half of a parallelogram is a triangle. So if I multiply both sides by 2, I end up getting this base times height is equal to area times 2, or 2a. Okay? So if I substitute what I know, 1.1w, sorry, the base is, I don't know the base, so we'll just make it a square, multiplied by the height. So a mystery number, we'll call it x, let's call the base x. So the base multiplied by the height is going to be the base, which is x, multiplied by the height, equals 2 multiplied by the area. If this makes sense to everybody, we good so far? All right. The base that we don't know, multiplied by the height, which we do know, is going to equal 2 areas, like we just figured out. So this is going to be, I'm going to change this around. Since we're multiplying an x variable by 11.1h, I'm going to think of it as a coefficient. 1.1h. I think I made this more complicated than I need to, but that's okay. Equals 6.6w squared. Divide both sides by 1.1h. I made a mistake here. It's supposed to be a w, isn't it? Oops. I couldn't read my own handwriting. W. 6.6 divided by 1.1 is 6. W squared divided by w is w. So therefore, the base is 6w. That was convoluted and probably unnecessary, but that's okay. That's how I solved it.